A cylindrical concrete tank of 40 external diameter is to be pre-stressed circumferentially. So it has been pre-stressed circumferentially of the concrete tank by means of high strength of steel wires. Young's modulus of the steel is given as 210 210 kilonewton per mm square. So then jacket at a 4 points 90 degree apart. If the minimum stress in the wires immediately after the tensioning is to be 600 newton per mm square and the coefficient of friction is 0.5. Calculate the maximum stress to be applied in the wires at the jacks and expected extension at the jacks. So this is what the question they asked. You take the general equation, px is equal to p naught e to power of minus mu alpha plus ki kx. Okay, but here the k value they have not given, so that's why you remove that part. See, uh, you see here, in this here plus here in this uh, px is equal to p naught into e to power of minus mu alpha plus kx it should become, but the k value they have not given. They had met so in order to meet the required answers, so you remove mu alpha plus kx is there, no, you remove kx, you remove, only you take px is equal to p naught into e to power of minus mu alpha. Okay, so px the px value, the whatever the tensioning, the minimum stress in the wires after tensioning, it is been fixed for newton 600 newton per mm square. So what you do is, for the px value you fix that as a 600. Okay, so initial stress they have not given, so you keep it that p naught. Okay, so p naught you keep it as it is, and rest of the things you substitute it. So mu, that is been coefficient of the friction, it is been given here, coefficient of friction here. Okay, here coefficient of friction 0.5 it is been given. So 0.5 in the value of mu you substitute the 0.5, and alpha value in the question only they have given as 90 degree. Okay, so 90 degree, in the place of 90 degree you substitute pi by 2. Okay, so pi by 2 you substitute it, and e will be 2 point the value of e will be 2.7183. Okay, so substitute this three values in that equation, then p naught you will get it around 1320 newton per mm square. Okay, so now what you have to do is, initially the initial stress you have determined, that is a 1320 newton per mm square. Then in the question they have said the whatever the minimum stress in the wires immediately after the tension is said to be 600 newton per mm square they are given. So there is a one stress of minimum stress 600 given, the initial stress it is 1320. So what you do is you take the average of these two stresses in the wires. Okay, initial and minimum stress. Okay, so 600 plus 1300 divided by 2, so that is what here we are doing here. Okay, we are doing that's what we are doing here. You have to take an average of the stresses in these two wires. After that you will get the average stress in the wires, it is 960 newton per mm square. Okay, so after that what you have to do is you have to find out the length of the wires. Okay, so for the length of the wires, you know that there is a 40-meter length. Okay, so that into 1000, the whatever the pi r, the length they are given, and divided by 4 you do it, pi dl you have to take it. So pi d divided by 4 into length you have to take it, that the length of the wires you will get it as the 10 to power of 4 pi mm. Okay, so that's what the length. So you should not take it directly 40-meter external diameter they have given, but length of the wires they have not given. Okay, so what you have to do is you have to find out the length indirectly, you have to do it. Okay, So take that and find the length of the wires. Okay, so after finding that, the extension of the, you want to find of the maximum stress you have already determined, maximum stress which has been applied. Okay, next is expected extension in the jacks you have to determine. So extension expected extensions at the jacks is equal to, so what you have to do is, this is what is 900 the stress you have to take it. After that, the stress is extension is nothing but deflection. Okay, that is nothing but strain. Okay, so stress Young's modulus is equal to stress Young's modulus is equal to stress by strain. So what you do is you interchange it. Okay, so E will go here, and Young's modulus will come to downwards. Okay, so small will go upward, and E will come to the downwards. So it will become extension of a jack is equal to E is equal to F by E. Okay, so the into L, you have to find out for the whole length, you have to take it now, that is for per meter length. For the what section you are taking, for the total length, that is pi 10 to power of 4 pi. So total extension will be 144 mm. Okay, so you may get confused. So that is for whatever the formula I have given, that is for per meter. But what is the total length of the wire sheet is 10 to power of 4 per mm. Okay, so that is the mm. So whatever you are taking, that is per mm. So this is for the total length of the wire. Okay, so that is per unit. Got it? So per unit, that is F by E, whatever it is there, that is per unit. But if you take the for the length of 10 to power of 4 pi mm, so you have to take it for that length, what is the extension of at the jack. So that you will get it, after simplifying you will get it 144 mm. So that's about this problem.